And so the next topic is, so we take a little bit of a switch and we start look from the bottom up. I'm not quite sure why researchers are considered the bottom, but anyway, that's a question for the discussion. So from the bottom up, from the researcher's perspective, I've got a couple of slides here with the help of Anne and Tigge. So,
but is that after the break?
No, we're starting now, and then we've got a little bit of a general discussion and some introduction to the aims of the hackathon based on our background that we're just working through now, and then we take a longer break after that. So I hope everyone's back from they've got their copies with them now. Right, so the researcher perspective, I just have to point out that in my previous life, I was a researcher, climate modeling researcher, but it's been a little while, so I would really appreciate for those researchers who are active at this time, please jump in and correct me where I go wrong here, and things may have moved on in the last 6 or 7 years since I've been involved. But yeah, please help me out here. Right. Right. Here we are. So here's a workflow that an idealized workflow of research. You come up with an idea, and then you think about the experimental design. You prepare your simulations and do this, and run the simulations, post-process, and analyze and publish. And this is nice. And the question here is, in terms of metadata, where in this workflow is metadata currently captured, if anywhere at all? And there's other questions about specific technicalities around storing NetCDF metadata, and if they're not in NetCDF, then where are they? And you know, where is the metadata generated, and where is it captured in this workflow? And people think about this sort of stuff. Adel has pointed to this particular activity, which has gone into this in a little bit more detail. You see the blue squares here are kind of like what we saw previously. That's the basic workflow, but around that there are things like administration activities, proposal writing, and publication stuff. Publication activities are in pink, and then there's blue is, the green is archiving activities. So there's interaction between the research workflow and archiving in this type of life cycle model. So there are sort of points along this workflow where metadata is generated. Metadata should be archived in some way, or collected and processed in some sort of way. So people think about this sort of stuff. Here's the idealized workflow again. I'll give you that for context. And this is my experience of what real research workflow looks like. Don't go into the details. I just pulled this off the web, but the point here is that it gets really messy because this is research, and you don't know the answer before you start, and things change. Adel also mentioned this in the previous talk. So everything in that workflow can change as the process happens, and you're doing things at the same time. Things very quickly get rather messy, and that's just life. And there's nothing wrong with that, because we're talking about blue sky research here. You know, it's not a well-defined process. It's very much discovery. So in that regard, how do we manage this mess? And there are things like workflow management tools, which are available. In my experience, using these tools, the uptake of using these tools is a bit slow, and hopefully that may improve. But for now, these workflow management tools are not that well widespread, as far as I can see. But I think they have real value in helping manage your the whole workflow. And maybe there's some scope for developing tools to help capture metadata semi-automatically or manually. So important factors for researchers that I could think of, that we could come up with, but again, please help us out here and give us your thoughts as well. One thing is that to work towards fair data and metadata capture, it really must require, well, I think it requires a minimum effort. And that's not to say that researchers are lazy or aren't interested in this sort of stuff or don't think it's important. Not saying that at all, but I think it's really important to remember that researchers have a lot of things to do, and the priorities are always on the publications and proposal writing and completing research. And so if on top of all of that, suddenly they're being asked to do a lot of manual time-consuming data management work, then that doesn't sit easily with these people, with research groups and researchers. And you know, that's understandable. They're very busy people, as we all are. Anyway, so and the other thing is robustness of the tools. There are some tools around that people use more in CNIP type work and things like that. And the feedback that I get is that they're not very robust and they're hard to use, and that becomes not a great experience for researchers if they're spending a lot of time trying to get their data management tools working. That's kind of frustrating, which is kind of ironic. It's funnily ironic because the actual models that people use, the Norius and ECRF and things like that, they break quite often, and they're hard to use and they're hard to install and maintain, but people don't complain too much about that. But when it comes to data management and things like that, then suddenly this is important. Okay, and then there's some questions around the details of to what level of, this comes back to the reproducibility and so on from the fair data side. People, I think the research groups and the researchers are still a little bit unsure as to what level of detail and what is expected in terms of reproducibility and how much detail you need, right down to, is it the exact version and the, you know, git commit hash for the particular software that I'm using. Does that all need to be captured, or is there a lower detail? So it's around how much detail is required, and nobody has really, it's unclear exactly these sorts of questions. So I think it's great to get an interaction between the fair data and the data management people and the researchers to clarify these sorts of things. And there's a bunch of, as I mentioned before in the workflow, there's a number of different places in the workflow where data is introduced and where metadata has to be captured, not just one place. Okay, and then finally, pain points. So Ada asked about pain points. These are the things that I can think of, or that we thought about. Data volume for climate modeling. Data volume is, they produce a lot of, the models produce a lot of data, and that's intimidating for people that are not specialist data managers. And finding storage and archiving space, it's just not easy. And moving stuff around and keeping track and things is not easy if you're not a specialist. Then again, archiving, so make sure when a project is done. So it's a sort of a, how do you make this data easy to find and use for others? And in particular, again, this is not specific to climate modeling, but if the project is finished and I move on to another project, then, but there's data the data from the old project, even though the project is now completed, isn't that, from a researcher perspective, then that's not my data anymore. Or like, you know, do I really have to have responsibility for that anymore, because that project is done and I'm looking at something else now, and I'm not, you know, that's somebody else's problem, maybe. But anyway, the tools for the data management, as I mentioned before, they're not particularly robust and difficult to install and use. You need to have a bit of experience before you can get these things to working. So that's the pain point for the researchers themselves. If they're expected to have to use these things, then they want them to work and they want them to be easy to use. And things like the documentation around model simulations is pretty sparse at times. One point that I'd like to emphasize is this training. To my knowledge, there's not a lot of training on how to manage data for the researchers themselves, on how to do it in detail, the exact processes that you need to follow and the exact steps that you need to make, tailored to climate modelers. I don't think that material is really available, as far as I know. And so, again, from a perspective of a researcher, you say, well, you hear this, you know, fair data management, that's the stuff you should be doing, and they understand that and they recognize it. But unless there's a very clear list of steps and tools and everything's ready for them, it's going to be hard to get people to do this sort of stuff, because from their perspective, it's not, you know, if I'm a researcher, it's not my job to develop a tool to get my data into a good state for fair state. And it's not my job to create a workflow to get my data managed. That's somebody else's problem. You know, I'm here to do research, right? And that's a fair point. So I think from the researcher's perspective, they would really appreciate having a very clear list of steps and a list or a process, and all the tools are available. I mean, that's what they would love to have. It's hard to do, but as I say, it's not, from their perspective, it's not their job to sort out all that sort of stuff. Yeah, and then retain details. So again, in terms of workflow management, making sure that all the different points along the steps there are ways to retain all the information, because there's lots of different steps. All right, I think that's all I have. So, does anyone have any? Oh, I should check that hackathon. But if you have any questions, feel free to ask.
Yeah, maybe I can just talk a little bit about this. I think this replicability, because I don't think we have talked so much about it. I mean, I think one kind of basic thing with fair data is that you can actually verify that data is correct, or why it ended up data ended up being like they are, or that they actually was the experiment was run correctly and so on. So I think one way to kind of measure how fair the data is could be that how easy is it to sort of to replicate it, the whole experiment. Is it possible even? I mean, I think most, if there are some years gone, I think it's often very difficult to actually replicate the experiment and the data itself. So how it was made. So and that comes down to, of course, also this what I talked about this, or what you mentioned, that hardware and software and so on kind of is out of date and it's difficult to replicate, but also that it actually misses a lot of details, which makes it very hard to actually reproduce. So you have to figure out a lot of things that actually wasn't mentioned when how it was produced. So I think kind of one thing to what I'm trying to say here is that one thing that researcher could have back in our mind is sort of thinking, will this be possible to recreate at some point in time? If you have that in the back of your mind, you kind of maybe could, it's easier to spot things that should be recorded along the way, because that could be kind of one good way to maybe think about a little bit more things to put into the data that will be stored. So that's a little bit just free thought from me, but maybe it's worth a discussion. Yeah.
I guess on the point of reproducibility, I think it's also important to recognize that climate models at this point in time don't have reproducibility, at least not necessarily. I know of climate models that will produce with the exact same binary, the exact same input and everything, but different allocation on the machines will produce different results. And of course, if you change the version of the compiler or compare one compiled with C-lang with the version compiled with Intel compiler, then almost all bets are off. Yep. So in this sense, reproducibility with climate models at this point isn't really a thing. And it's also not completely clear how desirable that is, or how high a priority that is in the community, for sure. I mean, if you're asking any model developer, do you want to spend, say, 1 person a year on making your climate model reproducible? I don't think you will find many groups that would be willing to do that. I think beyond that, in the wider context, maybe we should also clarify or make a little bit more explicit about what kind of data we're talking about. Now, in the last bit, I think it was mostly about the output from climate models. That's how I perceived it. And that's certainly a very big amount of data and also a very important part of it. But on the other hand, I also feel like that is somehow the bit of the ecosystem that is already best standardized and where the most progress has been made. If you compare how things looking now in CMIP 6, starting from CMIP 3, and I mean, the huge improvements have been made and the standardization is quite good. Other areas like the bits that come before, observations that feed into the models and that drive the models, but also bits that come afterwards, standard analysis like climate indices or similar things, are much less standardized. And I think if we could lift those bits to the level that we already reached with the models, that would be also a huge step forward. So I guess for me, it would be useful to clarify and or make explicit what really is the scope for this hackathon, and kind of for every bit to say whether we're talking about publications as in the very beginning in the first presentation, or specifically climate model output, or what exactly is the data that we're talking about.